Okay, so we left off at the end of the last video after seeing the UVs being properly corrected, that our lighting is still wrong, and we've been able to demonstrate how our tangents are not lining up with the tangents that are being calculated by Unity with the geometry that we've brought in from Maya. So in this video, Lee is going to change the calculation of our tangents such that it matches, or they match, the tangents that are being calculated by Unity. Lee?
Right. So the first thing we need to do is just to take a quick look while we're running and look at what's going on. With the mesh that's imported, our tangents, which are the ones that we care about, because the bitangents, if it's needed, are usually calculated in shader anyway. So we really aren't calculating these other than for drawing purposes. But it also helps to make sure when we're aligning things to make sure everything is aligned exactly the right direction, and we don't have something like the bitangents pointing in the wrong direction as well as the tangent. So with that being said, we see that their tangent is aligned in the negative x direction. Our tangent is in the positive z. So we're going to have to modify our code in such a way that we can calculate our tangents along negative x. So to do that is fairly simple once you think about it and look at the code. Now, based off of this, vector 4, which is our tangent, if I were to comment on our old one, we know that this one is calculating along the z-axis, so it's drawing a full space width along z. Well, we want to do the same thing, but not in z, in x. And not only in x, but in negative x. So we're going to set x to be negative fs. Now, the next part that we're doing is we're taking the height at the vector directly above and directly below this vertex. So we could put this in here if we wanted, but that's going to yield a wrong result because this is calculated based off of our vector being aligned north to south or along the z-axis. But we'll address that here in a sec. I just want it as a placeholder. Now, the next component is the z, which used to be a full space, but right now we're aligning along x and nothing in z, so z will be 0. That leaves us with our handedness, or our w, which we're going to leave as negative 1. Now to deal with our y. Because we're no longer calculating along the z-axis, but along the x-axis, we're going to have to change this. Luckily, we've already got the code to do that up here where we're calculating our normals, because we are pulling the samples from our left and right. So if we sample to the left and right of our vertex and get the slope across those as opposed to up and down, we can then use the right minus left will give us that slope that we can apply to y, which gives us our y component. That also means we no longer need the U and D component, so we can, or U and D samples, and we can pull those out. And I'm going to leave this here right now for just reference. So if we go ahead and, actually, I'm going to show two things first. I know negative 1 is going to work, but I'm going to leave it with 1 just so we can show what happens.
Okay.
So if we go ahead and run, let's say you weren't quite sure what you had and you figured 1 would be the correct number to put in instead of negative 1. So go ahead and run this. And if we look at first, it's go, oh, okay, I've got light coming from this direction, I've got light coming from this direction as well. The problem is, if you look, the light seems to be coming from the upper right-hand corner to the lower left corner on this example, but on our calculated, it looks like it's coming in from the lower right and going up to the upper left.
Right.
So this is because of the handedness, or the W being set to 1. If we go back and we flip this, and go ahead and run it again. And these are all things that we're talking about where we had to start changing things in pairs because we had UVs that were flipped. And we were flipping one and not the other, and we had to flip both of them, and then we had to change the handedness and then the tangents. That's the other thing. And speaking of tangents, if you look, our tangents are now all lined up the same way.
Mm-hmm.
So, and with flipping the handedness to be -1 again, our light looks like it's coming in from the same direction on both. So there's one other thing I want to do to make it a little bit easier to point out another problem that we've just created. So I know our tangents, our bitangents, and normals are all aligned the same on both. That means we can go ahead and go into our train patch, which we already are. We can comment out all this code again. Let's go back over to Unity. Go to our test plane. We don't need the tangential display script anymore. So if we build out, and I'm going to switch over to a top-down view on this, which flips everything upside down. Nice. All right, so let's click off. The very first thing that's apparent is the imported mesh has brighter highlights than are calculated. And we can adjust things. If we go to our directional light and I change our rotation, so if we look at 0, the problem becomes even easier to see. We've got very, very white, bright highlights in the direction of the light, which in this case is coming in from the bottom. So down here we've got very bright highlight. Across here is a bright highlight here, and along this edge. So every edge that is facing the light has got a very bright highlight. Our procedural does not. It has a highlight, but nowhere near as bright as what is coming in from our imported one. So these are the Unity calculated tangents, and these are our tangents, which gets to be an interesting problem. How do we get our calculations for lighting to be on par with what is going on with the lighting inside of the Unity calculations? So the first thing that came to mind was, well, they must not be normalizing their calculation. So what happens if I don't normalize my calculation? So I'll go ahead and not normalize. And if we compare again, all right, we're getting closer, except we're blown out a bit more than they are on their calculation. Again, if I go and set the directional light to an angle of 0, so we've got a little bit thicker highlight, and actually at 45 it was a little bit easier to see. So if you compare the two, we've got a thicker highlight that reaches a little bit further around than on the other side. So it's not that it's not being normalized, or it could be that it's not being normalized, but our underlying way of calculating the tangents are different. And that's probably going to be the case at some point. And I know that they're not calculating tangents the way we are because we're cheating our calculations. We're relying on the fact that our terrain is generated in a very specific way that allows us to use our sample heights and take a slope and set our tangents based off of the spacing that we have between each of the vertices. Their calculation is going to be probably more accurate because they've got to import models that aren't inherently all laid out nice, equally distanced. They're actually importing things like characters and spaceships and airplanes and everything else. So in the whole, keeping with our whole theme of cheating, we'll cheat some more. So let's just put a multiplier in. And lots of trial and error has led us to try about 1.45. Seems to be a good one for this particular example. So if I go ahead and play it with a multiplier of 1.45, we can see that our lighting is much closer.
Yeah, I think it's 1.
Probably a little bit brighter on our side still.
I think it's 1.55.
1.55?
Yeah, somewhere right around there.
Okay. So
yeah,
still probably a little bit on a hair light side. But at this point, we're starting to get nitpicky.
Yeah, very close.
So, but, if the highlighting is a little bit dimmer or a little bit hotter than, from model to model, that's not as big of a deal as the lighting coming in from a completely different direction.
I'm just making it very obvious now that
Right.
we're pretty much matching up almost spot on.
Yeah.
Very cool.
So now we can have some fun.
All right,
Now,
so let's go ahead and I'm going to, whoops, didn't mean to click
sorry.
there.
Yeah, go ahead.
It's all good. I'm going to go ahead and set this back to 45 and lift our X back up. All right, go ahead. Have some fun.
All right. Well, we've got our test pattern. We know our tangents are right. Our UVs are right. We fixed the bug with the UVs being all squiggly. So those are all taken care of. Let's see what happens when we put our height map back on, our height map normal map that we created. If I can find it. It was here somewhere. Yeah, kind of looks like this one. So now if we put this guy on.
Now I can see matching patterns very quickly.
Yep.
And I can also see matching lighting.
Yep.
It's almost spot on. Again, it's,
a little bit different in contrast.
Just a fraction of a hair, but I mean, it's going to be so difficult to see.
Yep. And instead of the magic number that we put in, if you wanted to put in a multiplier or a bias to adjust that, which is probably what we'll end up doing.
But that looks great because me personally, I'm having a hard time now and if I didn't know about the tangent length being different, I mean, just looking at this, it looks the same to me.
Right. So, but we do get the same results across as opposed to when we first started, where you're just like, oh wow, it looks like this here and completely different. Like it was an entire different set of textures and bump maps.
Exactly.
On this piece. So let's go and add the last bit back in, which is our color. So our diffuse map, which is our grass hill. So if we turn this back on, now this looks like one piece of geometry. So if I were to mesh this together,
with two little holes, two little triangles
with two
cut
little
out.
holes. So it's like going, oh, okay, it's consistent, and so this is no longer a concern to me. It's like, oh, it's all going to mash up, and the shadows are right. They match. They're going to respond to the light correctly. So if I change my angle, try 90. So other than a little bit of difference in contrast, we're getting pretty much even results all the way across.
Much better.
So, all right. So now, with that in place, we can go back and pretty much say, thank you for your hard work, test plane. We don't need you anymore.
I think
don't call us. We'll contact you.
I think that's pretty much everything. Is there anything? Oh, you want to go ahead and set this back now?
Yeah, I want to get it back in because it does bring up some other things that we need to look at. So if we're to go to 25 and let's do a spacing of 4. So we've got all that set up. Now, many of you, if you were like me, once you started getting bump mapping in, you start playing with all kinds of settings, trying to get it to look as good as you possibly could. You're going to find that once you go back, and there's one other thing I want to change here.
Put the scaling back in?
What's that? No, I want to leave the scaling out.
Okay.
I want to be able to control that by hand now.
Okay.
Because I've to the point in the R&D, I pretty much know what these settings are going to be. They're not going to be changed at runtime. So I don't need to dynamically adjust that. What I do need to do, though, is I want to get rid of the mini-map for now. It's taking up too much room in this small window. And it's served its purpose for now. So I'm just going to comment it out.
Okay.
But back to Unity. All right. Back to game. Go ahead and run this.
All right. Go ahead and let it bring those 25 patches in.
Yep.
All right. There we go.
So you'll notice things don't look quite the same as they did before. Because the way we're calculating our tangents, you've probably dialed in all your settings very particular to the way
That's right.
that was looking. So what you used to see isn't going to look the same.
No, nowhere near as contrasty as this.
Right. So if we go ahead and go into our material stuff, we can go back and start making some changes. We can dial up our grass down to about 5. And we can play around with some of these settings. Let's go with... let's try 3 to start with. So 3 and 3. Yeah. Way too dark in a lot of different areas. So that will be inside of our textures. Here's our height map. Now, we've got it cranked all the way up to 3, which is going to be way, way too high. So we can dial it down to, say, 1.5 and see where we get.
Which helps quite a bit.
Did it update on?
Yeah, you're suffering from the
Okay.
lag. Yeah, and the optimized display that's being sent over to you.
Okay, so that dials it down. Now you got to remember, we can't base the way the terrain looks on these 2 textures because this is, not the way it's going to look at all when we actually spend some time texturing it. This is just all for playing and trying to make it look good. So, I mean, if you turn this off, then we get just the height map information.
That's right.
And then this information in here, if you remember, we're getting the shadowing. If you want to spin around, I can't. So there we go. So our lighting stuff is coming in from our normal calculations. And if you remember back from those videos, we can adjust how dark the self-shadowing appears by either dividing or multiplying the Y component of our normal. So we can brighten things up or darken them. So anything you want to do, we can adjust. And we will, in the future, address doing multi-texturing with the terrain, which will help a lot. The other thing that I want to play with is multi-layering our bump maps. So we end up with things like a type of bump for handling rocks, a different type for grass, different types of terrain, and blending those all together. And then blending some of that out when we get really close to the camera, because when we get really close to the camera and it's these larger geographic type feature or geological type features that we're trying to simulate, we don't need to see those black bands right under ourselves because they just won't look right.
Right.
So there is one other thing I'd like to do before we hit stop on this.
Yeah.
If I go back to the texture.
All right, it's yours.
Okay. I want to see if we still have the problem with the parallax map crawl. So if we switch over to that.
Yeah, we do.
Okay.
I'm
so
not
I
even
can see.
having, all I'm having to do is just rotate the screen up and down and you can see it.
Yeah.
If you watch right in here, you can see it crawl.
Yeah, I can't see it on my side, but
There we go. For those watching the video, that should have been enough to, hang on now, there we go. There's another spot right here that I can get it to crawl really good.
see, even that one I can see.
Okay, yeah, that one's really bad.
Yeah.
So, yep, no parallax diffuse.
Yeah. So something else that I can experiment with, because I would really love to be able to
Oh,
use those
absolutely.
type of shaders, but not the way that Unity's implementing it with this particular solution. It just does not work.
Right.
And that big seam is not a
That
seam in the terrain.
No, that seam is actually found on the basic texture that comes from Unity in their standard assets.
Yep.
So in one of your other R&D ones, we really need to grab that texture. You took it into Photoshop, did the offset, and painted out the seam, and that made the entire terrain seamless. But unfortunately, at this point, it is back to the texture that comes
Well,
with Unity.
we can grab it really quick. It's because I've already got it on this system.
Okay.
So if we hit textures and we hit import new asset, it is here.
Jacked or
7.
07? Okay.
Oh, it's in 07 assets under textures, grass. I used what did I use for this one? I used my image synth that I got from Luxology
Okay.
to resample their information and created a new grass without seams.
Cool.
So
Did the import settings, were they all the way
yeah,
that
they're
you
fine.
want? Okay.
Yeah, with the base textures, I usually leave them default. There's no reason to change them.
Okay, fantastic.
So,
All right.
unless you
So
want to get crazy and do stuff like. But that kind of washes and makes everything out
yeah,
too smooth.
just a little bit. So is that pretty much everything that we needed to cover here in the errata for session 6?
As far as I know, until I find some more bugs in the code. I mean,
It's going to happen.
it's hard to find them though. I mean, I write such good code right off the bat every single time.
Oh
It
yeah.
at least takes a good 30 seconds to find the first error.
All right, fantastic. Well, we'll go ahead and call that a wrap then on this section, and that will then enable us to move on into session 7, which is going to be the basic sculpting system. So thanks a lot, everyone, and that's going to wrap this up.